Hey boys and girls, Mr. D here. In this video we're going to take a look at how to identify and combine like terms. So let's jump right in, we'll take a look here. This is a very important skill that you need to have in order to move forward and master really everything in pre-algebra, algebra, and so on. So very critical that we get a good understanding here, and after watching the video you should have a great understanding of it. So take a look at the first example here. We have 3x plus 7 plus 5x. Okay, so when we talk about like terms, this is really important here. When we talk about like terms, we're talking about the same exact variable having the same exact exponent. Okay, so on our paper right now, let's circle the terms and circle the whole term. I know in class we did an exercise where we circled just the variable. I'd like you to circle the whole term that has the x in it. Circle the terms of the variable of x. So I see an x here, so I'm going to circle this whole term. Okay, I see another x here, so I'm going to circle the entire term. And I'm even going to circle the sign in front of it. In this case, it's a positive, but a lot of times when it's a negative sign, if we don't think of it as going with this term, we get confused. So remember, whatever sign is in front of the term stays with it. Okay, so let's take a look. Let's identify our coefficients here. Remember, a coefficient is the number that's being multiplied by the variable, or the number in front of the variable, essentially. So our coefficient with this first term is 3. Our coefficient in the second term is a 5. Okay. Now, when we combine like terms, we're just going to add and subtract as we would regularly. And we just sort of bring the variable along for a ride. So, that being said, we've got 3 plus 5. Right? Just add and subtract how you regularly would. 3 plus 5 is 8. And just carry that variable with you for the ride, so 8x. And then we haven't done anything with this 7. We'll just bring down, that's our constant, that's what we call that, that's our constant. It doesn't change, the value of 7 doesn't change, it's 7. Again, these are our variables, because we don't know what x is in this case. It can vary, okay? But 7, the value of 7 is always constant. Okay, it's 7. So 8x plus 7 would be how we'd simplify this. Again, if you think about it down here, just logically here, we've got 3x, right? 3x's, 1, 2, 3, and we're going to add 5x's. 1, 2, 3, 4, 5, and all together that would give us 8x's. Okay? Let's take a look at another example. Example 2, a little more complex here. Here's your equation. Take a second, write it down. Pause the video, and then unpause it when you've done writing it down. Okay, so hopefully you've got that all written. Again, same exact variable, same exact exponent. Okay, so we're going to try and reorganize this expression to group the like terms together. This will make it easier to combine the like terms. So let's start off by identifying the like terms. Okay, so use my little highlighter here. So let's start with our constants. We have a constant of 4. We have a constant of 17. Okay, so 4 and 17. Oh, 4 and 17 are like terms. No, they're constants. They're and then let's take a look. We got our x's here. X, x. So we've got 2x, and we got a 7x. All right. Y's. There's a y, and here's a y. Look, keep that negative sign with it. Okay. We got 3y and a negative y. We don't see a number right in front of this y here. Technically, that's a 1. That's negative 1y. Okay, we don't usually write the 1 in there, but I will for now, so you see it. So I went ahead and reorganized this. So here we got our 4 and our 17 together. Our x's are together right here. Our y's are together. And there's really no like terms with this x squared and the y to the 4th, so we just keep those at the end there hanging there. So again, let's combine, add, subtract how we regularly would. All right, so 4 plus 17 is 21. 2 plus 7 is going to give us 9, so that would be 9x. 3 3 minus 1, again, there's no number in front of this y, so it's just 1y. Right? So 3 minus 1 is positive 2. So it'd be 2y. Alright, and then here we've got 5x squared. There's nothing to go with that. Just bring that down. And then the 12y to the fourth, negative 12y to the fourth, nothing goes with that. So this is how we would simplify this expression here by combining like terms. Okay, so please make note of that. And here, take a look here. Example 3. This is a long one. Copy it down. Separate sheet of paper, please. Name and honor code. If you can get this one right, could end up on the wall of fame here. So name, honor code, separate sheet of paper. I'll collect this separately when you guys come in. Alright, so make sure you identify the like terms, and then give me the combination of like terms. This is a tricky one. There's a lot here. If you can do this one, you are certainly on your way to being a master of understanding like terms. If you don't get this one, don't worry about it. We'll do some more simplified versions in class, which will follow a lot more of the first example and even a little bit of the second example. But if you get a good understanding of the first example especially, we'll work with it from there. Here's a good challenge problem, and I'll see you guys in class.